All right, great. So now they're all copies, therefore we can modify them. Let me just show you once again how I modified the original classification codes we made before to these new ones, more simplified ones, which will get you the accuracy quickly and efficiently. So the data preprocessing phase, I kept exactly the same, including, the feature scaling applied to xtrain and xtest. But here I put a template name and I highlighted that you have to enter the name of your dataset here. So that's what we'll do. I'll show you. But that's the only thing that was changed. Indeed, we don't have to do much else because this will automatically select all the features and not your dependent variable. And this will automatically select your dependent variable. And that provided, of course, you have in your dataset first the features, in the first columns, and last the dependent variable in the last column, right? Make sure of this. What we're going to do now works for any data sets regardless of the number of features, as long as they have the features in the first columns and the dependent variable in the last column. Make sure to remember this. All right, and then all good here. If you want, you can change that from 0.25 to 0.2, but that's fine. Both values work well. Then feature scaling. All right. Then for each of the classification model, I kept, the code to implement and train it. And finally, what I did in the last cells is simply I removed, the prints that displayed the vector predictions and the vector real results next to each other because, we don't really need it for our model selection process. However, what I did is that I kept this, of course, but in order to compute the confusion matrix and the accuracy, I had to create that ypred vector containing all the predictions by calling the predict method applied to xtest from our classifier. And that's all I did. And I did the same in all the different files, right? K nearest neighbors, data preprocessing phase, training and confusion matrix. Same support vector machine, data preprocessing, training and confusion matrix. Then kernel SVM, same, data preprocessing phase, training and confusion matrix. Naive Bayes, data preprocessing phase, training and confusion matrix. And decision tree classification, data preprocessing phase, training, confusion matrix, and finally, random forest, data preprocessing phase, training, and confusion matrix. See? So you have the exact same code templates for each of the classification models we built together. The only thing that changed is actually this cell, because this cell actually builds and trains the classification model you want to try through this model selection process. All right, perfect. So now we're getting very close to the demo. And so just to recap, this demo works for any data set, regardless of the number of features, and as long as you have your features in the first columns and your dependent variable in the last column, and also as long as you don't have some special data preprocessing tools to use on your data set. If you have any categorical variables, in strings or categorical variables where you have to perform one-hot encoding, well, don't forget to use your data preprocessing toolkit to preprocess the right way your dataset. And then you can just deploy all your classification code templates here. And that, my friends, is exactly what I'm about to show you right now. So now the demo is going to start. Are you ready? 3, 2, 1, go. All right, so I'm going to do this as efficiently as I can in order to show you the power of code templates. So the first step is to upload the dataset inside the notebook. Right now it is connecting to runtime to enable file browsing. Actually, I'm going to do this for each of the models here because, it always takes a few seconds. So let's do it this way to be efficient. All right, so I'm just, loading all the files here. All right, perfect. And everything, every file is now connecting to a runtime. Now be careful. If you don't see the sample data here, you have to refresh. Otherwise you will have issues uploading your dataset. Good, now it's good. So the next step, we upload the dataset. All right, so this is the model selection folder and more precisely the classification folder. But let me show you the path again. I put this machine learning model selection folder into my desktop, but make sure to find it on your machine wherever it is. If you have not downloaded that already, make sure to download it right before this tutorial in the article. You will find the link at the bottom of the article. Then together we're going to go inside, then inside classification, and there we go, we select data.csv. Then we click open. Then we press OK, and then what we simply need to do inside this code template is just to put here the name of the dataset. So you just double click this and then enter data.csv or, the name of your future dataset. All right, and that's it. That's all we have to do in each code template. Only one thing to change so that we can really call it a code template. All right, great. So now we're going to do the same in each other implementation. So now k nearest neighbors, let's refresh this because we need to see this. There we go. Then upload, then data.csv, then open. All right, perfect. Okay. And then we replace here the name by data.csv. Perfect. Then next one, support vector machine, refresh, upload, then data.csv, then open, and perfect. We have the dataset. Now we replace this by data.csv, and all good. SVM is ready. Now kernel SVM, refresh, upload, data.csv, open, okay. Replacing this by data.csv or the name of your future dataset. And there we go, kernel SVM is ready. All right, then naive Bayes, refresh, upload, data.csv, open, okay. And then replacing this by data.csv.